This video we're going to talk about compound interest and do an example using compound interest. So if you think about it, when you have something that you're paying monthly on, or you have a bank account and the bank is paying you monthly on, they're paying interest into your account. You would have an annual interest rate, but it will be compounded monthly. So when the interest is paid monthly, the interest earned after the first month becomes part of the new principal. And remember, the principal amount is that initial amount for the second month, and so on and so forth. Interest is always earned on the interest already earned. So this is compound interest. You're compounding. You're earning interest upon interest upon interest upon interest. So the compound interest formula, let's write this out. The compound interest formula has some parts to it. You have your principal investment. So the ITIAL investment. And this is your principal investment. So your initial principal investment. You have your rates. So this is your annual interest rate. And it's usually written as a decimal. We'll say it in a percentage, but it's typically written in decimal form. N is the number of compounding periods per year. Number of compounding periods per year. And then A is going to be the value of the account. All right, so here now we're going to have the equation A, which is the value of the account, equal to the principal investment times 1 plus, and this is starting to look like what we've seen for population, but here's where they differentiate. You have rate over the number of times it's compounding, raised to the number of times it's compounding, times t. All right. So I would pause the video here. I would add t years to this, and I would make sure that this is in your notes. This is a compound interest. We will be using this formula, especially when we talk about loans and talk about buying a car, buying a house. You can use this for college loans, or even you could look at this when you have a savings account in the bank. They don't pay as much for their rate, but they do pay a small amount because they do borrow your money. So there you go. And pause this here and make sure you get it written down. All right, so welcome back. If you left, if you didn't leave, then we're just going to continue on. So we're going to look at an investment. We're going to look at Tamara's investment. So Tamara invests $5,000. So she's investing $5,000. Oh, that looks like a 1. Let me clean that number sign up a little bit. There we go. In an account that pays 4% annual interest. So her rate is 0.04 per year. How much will there be in the account after 3 years if the interest is compounded annually, semi-annually, quarterly, or monthly? All right, so let's look at annually. So using that formula, we have A equals 5,000, her principal and our initial investment, 1 plus 0.04 divided by n. And remember, n is in t years. So we're looking at 1 year. And if we're looking at 1 year, then my n in this case is going to equal 1 for that 1 year. So this is going to be 1 raised to, we're looking at 3 years because we want to know what her investment is after 3 years. And using a calculator just to be a little bit more accurate, we're looking at $5,624.32. Not bad. She made in 3 years $624 just allowing her money to sit in an account. So let's talk about semi-annual. All right, so semi-annual means it's twice a year. So this is going to be 5,000, our initial principal, times 1 plus 0.04 divided by 2. And then that's 2 times 3, or 3 times 2, because my n here is 2. All right, so what I come up with here is going to be 5,630. She's making a little bit more money with a semi-annual account. Okay, quarterly, that's 4 times a year. So again, same equation, 1 plus 0.4, but we're looking at 4 times a year, 3 times 4, and what she gets is $5,634.13. So she's slowly accumulating more and more, and if I look at monthly, she makes, on the monthly, I'm going to put monthly in this corner because I'm running out of space. Again, there's 12 months in the year, so monthly at the end of that one, she gets $5,636.36. So as the number of compounding periods increases, the amount in the account also increases. So it is beneficial for you as a saver to get a good rate, and then you could actually grow your funds just by letting it sit in the bank. On the flip side, it's bad for you as a consumer if you use a credit card with these interest rates and you don't pay off your full amount, because now the bank is making the extra $634. You might be paying an extra $634 on something that you pay $5,000 for. So almost another $1,000 if it was the flip side. All right, so there is the compound interest. There are the different ways that you can do it, how you can compound it. And again, if you have any questions, always feel free to ask, get a hold of me, and hopefully I can answer them. We'll see you in the next video.